Hi everyone, my name is Stepan, and today I will talk about the absolute modularization in the Android world. I have a great experience working with Android apps. My first app I've started to build around 10 years ago, a bit more. And right now I'm focused on build systems and developer operations. And my main area right now is autonomous vehicles at level 5 Lyft. So yeah, let's get straight to the topic of our discussion. And the first thing first, and I want to warn you, things I will be talking about today is a bit controversial. So I just want you to understand that there is no shortcuts for good engineering. And if you think that there is something which you can avoid doing, think about it a little bit more and really try to understand the reasons why you still want to do something like extra to make your life better as an engineer and raise up the quality of your work. So today I will be talking about problems of the big projects, how we define the project structure, and what actually needed for successful developing of large applications, especially for mobile. So I want to start with definition of the project you can experience, definition of the problems you can experience while working with the big projects. So the first thing is the complex dependency management. So basically, every time you want to update something significant, you end up trying to resolve version conflicts and kind of work around in case of Android, the Gradle definitions and Gradle APIs of dealing with all these dependencies. Another thing which I personally faced a lot of times is copy pasting of the model configurations. The problem is most of the developers, they don't understand why some particular pieces of build configuration appear in build files. So they just copy pieces from the models they are familiar with and create new models with existing configuration, which can be and most of the time is not the best way of doing it. And this leads to some redundant plugins which just applied to some particular models because it's been copied from somewhere else, and at the end it leads to long configuration time, long build times, and more complex management of entire build configuration, which is usually handled by a separate team. Another thing for the big projects, which is really important, is an ownership. Sometimes structure of the organization change and some modules are left unattended. And then it's pretty hard to kind of refactor the pieces of the app because no one really owns it. And there is no really a way to enforce some ownership on some modules. Unrestricted visibility, it's pretty much the same concept which you find in Java, Kotlin, and other programming languages. And all developers are familiar with it. But when it comes to build configuration, the visibility, mostly forgotten and nobody actually pays attention to it. And it leads to some modules being used in places they were not designed to. And in case of a big project, it again leads to longer build times and much harder refactorings. And yeah, so basically, overall, all these projects, all these problems combined leads to the fact that structure of the project, it's not really scalable. So you can't keep just copying configuration from one module to many modules without actually understanding overall scheme of how these modules interact and depend on each other. As a quick examples to my last point, it's feature-to-feature dependency. Let's say you have like one big screen and you need, I don't know, just navigate to another screen. And to do that, you actually add a dependency to entire feature. And once you do it a couple of times, it leads to long dependency chains, which hit the build time really hard. So a lot of times I've experienced like developers just adding KPT plugin to all the modules in the project just because it's so convenient. Like if you copy it everywhere, you don't need to think about if you need it or not. It's always there. But again, this hits build configuration and compilation time pretty hard. Another thing is the code structure. Maybe you are structuring the code as proposed by Google, like having the one core module, and then you have a feature modules, and then you have an app module. And this is, again, doesn't scale because you will eventually have feature-to-feature dependency, stuff like that. But the other problem is it's pretty hard to navigate across this project, and it's pretty hard to find the pieces of code you're interested in because you don't really know where some particular functionality are stored if a feature depends on like another feature, and like even worse if you're using like API definitions, so all the modules kind of depend transitively without explicitly declaring what depend on what. So you kind of have access to everything from every place, but you don't really know where it's stored and where you probably should have been stored in terms of like project structure and proper code sharing practices. So yeah, so how do we handle that? Like what tools we have to help us with it? And I want to like step back for a little bit and see like how actually management of the code was evolving over time. So maybe no one remembers it, even me. And like years ago, there was only code in the folder, and then you can just keep coding, and there was no really a version control or something like that. And most of the project was just CLI utils like, I don't know, grep, find, stuff like that. And you don't really needed any like versioning because mostly it was one developer who was working on a single, pretty small like app, and it changed like pretty fast. At first, it was just to version archives. I used to do it back in the days. You just zip your folder, put the version in it, and then code for a couple of days and zip it again and hope it doesn't go anywhere. And after this problem was acknowledged, there was the era of version control systems. So you can have like branches, versions, tags, and stuff like that. And you have like pretty awesome tool to work in a team on like really big project. And then, of course, it wasn't enough. And every change you need to validate because, yeah, when you have a lot of people, it's like pretty hard to keep everything consistent. So the continuous integration comes in. And like on top of that, to really understand what's happening with a project, on top of continuous integration, most of the big companies, they put some build metrics into that. And this works pretty well, but one day your project can become so big that you need some like extra tools to help with that. And I will talk a bit about it, and I will talk about how tools, which like I imagine would be the next step after having build metrics, can help even smaller project to achieve better code quality and like faster build times. And the solution to that is to give the build system a knowledge about team, give the build system knowledge about how to teach developers to do the like better engineering in terms of code structure, and actually enforce this structure on developers so they will think in terms of properly structuring the project as opposed to thinking about how to write build configurations. So yeah, it came to the teaching build system a new tricks. And to actually learn something new in terms of build system, we need to forget something we already know. So the build configuration, and this is kind of pretty controversial topic. I don't think the build configuration is a good thing to have in the project, because at the end, nobody want to know how the project is built. Even the engineers who work on that, the only thing which makes sense for the project is its structure and how the organization actually influence structure of this project. So, and basically, I would be happy if I would not be forced to work with build configurations and only kind of think in terms of components and how these components are related to each other. And let's see it in practice. So how I want to see the project structure definitions and work with it. So the first thing is the project structure. The bigger the project, the more project structure would be similar to the structure of organization. So you sometimes have business units. Let's say I was working on the app and we had payment organization, transport organization, then we had promotion and benefits organization, and many more. And every organization had internal structure which differs across these organizations, but at the end everyone contribute to the same project. So we need somehow to maintain all these cross businesses dependencies, and really it would be really beneficial to for developers to understand from the code structure how these organizations relate. So pretty much what else I want to see there, it's really project configuration, which kind of lacking in Gradle, because Gradle doesn't really know if you building one single application or just tens or sometimes hundreds or thousands smaller apps with kind of just have dependencies on one another for some reason. And also I want to know module type, module owner. I want to have the visibility, and I want to enforce some rules on these modules, which is extremely important piece if we're talking about the product structure, because this is pretty much the same thing you have in the org. You have security teams which enforce some rules on developers and on organization overall, and the processes which restrict one people from doing one thing and then the people from doing another thing. So this is pretty much the snapshot of this vision. And yeah, let's talk from top to bottom what this scheme actually means. So the first thing, and this is kind of related to mobile apps mostly. So for example, I want to have the build configuration, which will build me, release, and debug, but I don't want to think about it as a build configuration. I want to just have kind of separate project. So I will create the modules, which will be the app release and app debug. And let's say I will create some module type for it. Call it, I don't know, application, Android app, something like that. Sorry, not Android app, Android binary. And then when we have different Android binaries with different configurations, which we usually have in Gradle in a single module, these binaries would depend on Android application, which is pretty much aggregation of everything we want to include into our binary. And here in the binaries, we would have some thin layer of definitions of this differences between release and debug version. Maybe it would be keys, maybe it would be package name or different packaging rules, different program rules, something like that. And now we have the Android app in here, and we want to add dependencies to all the features we have. So here on this scheme, it's only like 2 features, feature 1 and feature 2, but of course you can imagine it could be like much more. And the important thing to notice here, so we have this kind of folder-like area. This is pretty much a package. So basically a folder where we store modules named feature IMPL and feature API. And as you can infer from the name, the APIs is just public definitions of how one feature would interact with another feature, and implementation, it's the actual implementation. There is a kind of pattern which very popular in enterprise applications and not really popular in mobile apps. But I think it's pretty important to enforce these pieces on especially like medium to large Android apps. And this is for a couple of reasons. One of it is clear separation of concerns, or you can call it like single responsibility. So we want to get every module that we have some single responsibility it would be handling. And this is definitely not happening in the pretty much anything that I've saw in the Android world. So one of the benefits here we see if feature 1 can depend on the feature 2 APIs without actually depending on implementation. And since APIs is just an interfaces with some definitions, these modules like feature 1 IMPL and feature 2 IMPL could be compiled in parallel without any dependencies between. So this will help us to achieve much faster build times. And this is kind of one of the pieces I was struggling with for years, like working on the large Android apps. And here, what we can see here, we have the network. Let's say this is just an example, right? So we have this network library and network utils. So the library and util, it's different types of modules as well. So the library, it's some pieces of functionality which is not actually a feature. Let's say if we would build something like retrofit inside our application in a separate module, it would be something like that. On top of that, we have some utils, and the easiest way to think about it is, for example, network library would be Java, and network utils would be ADX extensions. So here, the dependencies from feature 1 to network and from feature 2 to network actually means that these two features use some network calls, and they only depend on utils, and utils depend on network library. And on the scheme, it's not like super visible, but I will talk about it a bit later. This is actually the single dependency which encapsulate multiple modules. And here we see widgets. Widgets also the separate type of modules, and the widget, it's as you can imagine, just a view. So here we can see like first and second widget, they share string resources, which is also the separate module designed specifically to handle resources. And building the modules this way, we will not allow any other modules to have resources in it. So this is like another layer of restrictions to help us to achieve like better code structure. And this is pretty much mean that these like feature modules, you will not have this like luxury of copying over string resources, which I've seen like a lot of times, and it leads to inconsistency in the translation and like extremely hard to support like pieces of internationalization. And here we can see the view resources, which is also a separate module which can be shared across multiple widgets. I could have added another dependency between widget 1 and view resources here, but this is not really necessary since it's just an example. And I hope right now you can kind of have a bit of taste of how this actually came together and why we need so many different module types with the different types of restrictions in there. And at the end, it just gives us a better understanding of how the project structure and help us resolve some of the common problems, just because it's not possible when you restrict modules to only have some specific goal for existing. And this is pretty much how you can specify project configuration. So this is, I can say it's like half of just an example. And the second half, there is actually a real implementation underneath. So you can see this is pretty much everything that you want to supply to all the modules in your entire project. If you're talking about Gradle, so which is like minimal SDK, target SDK, Kotlin version, Android plugin version, and stuff like that. And usually, what's happening is people either or copy all the configuration which involves these values across multiple modules, or some smarter developers write some custom solution to share this logic across multiple modules using stuff like subprojects block, which in Gradle allow you to apply some pieces of build logic to every module. And once project grow a little bit more, it kind of introduce a lot of if conditions. So like if module name, blah, blah, apply like this piece and other. So this is more like cleaner way of declaring configuration, which would be propagated to all the modules we have. And this is just an example of the typical build configuration, which I've saw in many Android projects. And you don't need to like try to read what's happening in there. It just important to notice. So this is like 50 lines, and like more than half of it are just copied across multiple modules usually. And how we can fight this, how we can structure our project in a way we will not require this amount of work, and we will not require a separate engineer or separate team to help us extract pieces of it in the separate files. And this is pretty much the initial design of a solution, which consists from like multiple pieces, and I will go through it with you like one by one. The first of all, it's the type of the module we want to use. In this case, it's Android library, so it's pretty much relates to the plugin, which is com Android library, along with some more plugins supplied like gCoco, Kotlin, KAPT, and stuff like that. And here we declare the package name. The package name really corresponds to the name we put into the manifest. So this is like pretty obvious. And dependencies, it's kind of pretty much the same thing that we have in a plain Gradle, but it introduces a bit of restrictions in there. And the biggest piece to notice is that you don't actually need to specify the type of the dependency you add. So you don't need to think about would it be like API or implementation or compile only or in time only, or there's some other types of dependencies you could have been using. So here it came to like one simple thing. So you just specify the list of dependencies you need. And here you can see we have the dependencies where we pass libraries. And later on, I will explain why is that, like how do we have this fancy names for these libraries. So it's pretty common practice right now, putting it in the build SRC. And here we have plus dependencies with the projects. So one of the goals here for the design of this API was to make it type safe. So basically what happened in Gradle, we have this dependency block, and it accepts object of type any if we're talking about Kotlin script. And this is pretty much like breaks all the type safety which Kotlin provides to us. So here you have a special method to handle dependencies, like an external dependencies in terms of libraries. you get from like Maven or JCenter or somewhere else, and internal dependencies, which is your projects. So you need to split it up to really have a better visibility on what you own versus what you get from some external sources. And here, the really important part, it's the owner and visibility. So the owner, you can specify the team or a person who owns this module and who is responsible. And what I usually do, like when I open the files in Android project, I just go to git blame and see who was the author of this file or the line which I'm interested in. And here, this is kind of a small bonus. You can say, so you don't need to do it. So you just open a project structure definition file, which you will call it now because there is no build configuration right now, and see who owns it. And once you navigate to the team score, you can see the list of the people who actually correspond to the team. And the same for visibility. So the visibility I will not touch much because the API is not fully designed yet, but it actually allow you to restrict some modules from being accessed from another modules. So as you can see, this is like very different from how we used to build the Android apps with Gradle right now. From one side, this approach is more powerful in terms of you see like who's the owner, you have like smaller size of the project structure definition compared to build configuration. But from the other hand, it's less flexible. As you can see, there is no obvious way to add some extra plugins or I don't know, do the fancy stuff that you usually do with your build configuration, like creating new tasks and stuff like that. So most of it, it's not really accessible. But I see it as a good thing because if project structure definition will do everything that I want, why I want this extra flexibility? Of course, this is like a big question. Like, can this API handle everything? But yeah, I guess we will answer it a bit later. So, as I was saying, I see lack of flexibility as a good thing, and especially with Gradle, because Gradle allow developers to do like really crazy stuff, and this is especially noticeable when you try to use some the new plugins, and these plugins could actually like modify the entire build configuration of whole project, and sometimes it leads to like really hard to debug and understand errors. And yeah, I was personally struggling with that for a long time. So right now, personally, I'll prefer to have something very simple, which will not cause me any trouble. And like if I really sure that, yeah, I need to use like some extra plugin and this plugin actually will not break me anything, then I will do it. And like the most important part about having the flexibility is actually slowing developers down, not because they can't do something, but because there is so many ways to do some like very simple thing, especially in Gradle. So many times it lead to the like long arguments between developers, like how to do it better. So yeah, this is what we did. We make configuration less flexible, and we introduce a lot of different types of modules, as you can see. And some of them I was like talking about it previously, like Android binary, like Android library, the features, which consists from like API and implementation, widgets, utilities. There is also like the test utilities, which is type of module you can only add to the test dependencies and let's say the data bindings. I don't recommend to use it, but yeah, there's an example for it as well. Some configuration module with like resources only, and you're not allowed to have resources in any other modules, including the widgets. And if you have questions about it, I will be happy to discuss after the talk. So, and probably more because as we have like in any project, we have a lot of interfaces we interact with. The same way, if we treat the build configuration or project structure configuration as a code, we will need to introduce some interfaces or classes on, or in this case, module types, which will correspond to every use case we have in our project. And yeah, it sounds a bit weird right now, especially for developers who used to have like single module type for pretty much everything, be it like set of resources or entire feature or some library or utilities. And right now, you actually need to think about what the purpose of the model you create. And this is pretty much the point that I want to convey here. So we need to really understand why we're creating modules and what should be in there, because without this understanding, a lot of modules just grow to the like really huge size, and then again it leads to like really hard refactoring, and people don't understand what's actually going on in the project. So to sum it up, the aim here is to introduce some abstractions which would force you to use single responsibility, would be type safe, introduce some dependency restrictions, and also different types of restrictions. Like for the module with resources, there is no reason for having any code in there. The same way for the other modules, if you already have the separate type for resources, there is no reason to have resources in the feature module because you forced to extract it separately. And no direct access to plugins, which is a good thing, but of course there is some work to do to actually introduce some way to have an access if you really need it. So I was talking about inversion of control, and now when we're talking about all these different types of restrictions and the single responsibility, I hope you start to see this idea of how these restrictions actually change the control flow. So previously, developers were telling build system what to do and how to build the project, and right now, the build system tells you like, hey, you did this wrong, you can't have this file in this module, and stuff like that. So basically, now build system controls how developers structure the code and not vice versa. So now I was talking a lot about all these different types of modules and how all these different restrictions can help us, but do I think that this like single set of modules fits all the use cases in the Android world? Probably yes. And if you see some use case which is not really covered, please let me know. So here I would be summing up some of the like types of the modules and different types of restrictions to really help you understand what exactly I mean by that. So let's say Android binary, it module which applies COM Android application plugin, and there's only a module which allowed to have it, and it doesn't allow any code in there, any resources, or annotation processing, except for data binding use case, because you can't really avoid that. And it's actually came down to having manifest and some extra configuration to produce the binary artifact. So I hope this kind of makes sense, especially after you used to kind of have the single module, which right now, as I was showing on the example, split it on three, like release, debug, and also like Android app. And Android library, pretty much piece of shared business logic. It also doesn't allow any resources and doesn't allow dependencies on other Android libraries to enforce kind of strict separation between it. Of course, this is not kind of the end design, and maybe it will be changed in the future, and most probably will. But yeah, right now it's kind of like that. So the feature, it contains the business logic but it doesn't allow resources and doesn't allow direct dependencies on other feature. And by other feature, I mean the feature implementation. You can still depend on APIs, and you can pretty much depend on APIs everywhere except for the libraries and utils, because why the library would need some API of the project feature? Because libraries is usually like low level. Test utilities. Test utilities is pretty simple. So basically shared pieces of logic you use for tests, and you cannot add the test utility to the dependencies of your feature or library, something like that. You can only add it to the test dependencies, which I hope makes sense. And the resources, as I was mentioning a couple of times, there's only type of module which allow resources, so other types not allow it. And yeah, you kind of need to extract all resources separately and then add it as a dependency. The widgets, this is pretty obvious. It module especially designed to contain the views, and yeah, I'm saying here it allow dependencies on external libraries, but yeah, it actually not true. I realized like yesterday, so this is not the best way to do it. So the widgets should be self-contained, and I will probably restrict it in the next version. And yeah, so I will not be walking you through the all types of modules. It's just a small examples of like why exactly this type of restrictions enforced on certain types of modules. And yeah, to sum it up, I probably agree with you. It sounds like an overkill having so many different types of modules and forcing developers to split modules, which usually was like one single piece, into multiple different pieces. But yeah, it sounds like that. And it seemed like that. And even if you try to do it, it feels like a lot of extra work. But from my experience, this work is actually pays off, and it pays off like much faster than you think. And the only kind of downside of it, if you will structure your project properly from the beginning, of course there will be hard to measure like how it impacted your development flows. And one of the bonuses of this structure, it's actually effectively scales. It may sound like not big of a deal for most of the projects you will probably work with, but if you're reaching the limit of like few hundreds of modules, this is extremely important to keep adding more and more modules without heavily impacting your build time and your developer experience. And the structure which I'm proposing right now actually covers that. So one of the like extra benefits, it's you don't need to have the entire team of build engineers if you don't have a build configuration. So the project structure could be handled by common engineers, I would say, which doesn't have a lot of experience on different types of build systems. So I was touching a bit the dependencies API, and let me go through it like pretty fast. So usually we have a lot of different types of configurations in a project, and I don't think we need so much. I usually only use implementation. So and why not design some slightly better API to use the dependencies? And this is how it looks like on the paper, I would say. So you have this like the object you create, and you'll build a SRC, and you can kind of just create the variable and assign to it some string and call dep. I would say it's like property, but actually it's just a method call. Looks a bit nicer without actual brackets. And it will transform your string to the actual dependency, which can enforce certain types of validation. And here you can see how you can create a single dependency which consists from multiple dependencies. And here there is an example, like in terms of in case of Dagger, Dagger have the single dependency, which is Java X inject. And here, if we're using deps, you actually kind of forced to specify of all the transitive dependency. It really helps when you have problems with the version conflicts. And if you don't really want to deal with the transitive dependencies, you can use the transitive deps, and it will work pretty much the same way as it works by default in Gradle. And here, this is, again, a good example how we can combine multiple dependencies into the single one. And like the next time you want to use retrofit, you will actually know it contains like OkHttp and OKIO, but you don't need to kind of add the OkHttp and OKIO to the dependencies because the retrofit have it all inside. And it may seem like a bit an overhead here, but I wanted to kind of focus your attention on the fact that here, while we're using retrofit, we actually force certain version of dependencies that we're interested in, the OKIO and OKHTTP, which is not really happening if we just use the retrofit alone, because most of the time we don't really know what version of this OKIO and OKHTTP would be added to our module transitively. But right now we actually knows. And what is the other benefits of using APIs like that? This is pretty much due to the fact that we hide all the build configuration from all the modules. We can adjust and add new functionality under the hood. Let's say Jacoco reports. Big projects have it for every modules, and nothing stopping us from introducing it inside our API, and then we don't really need to touch anything inside the project. So just one place change, which will be applied to everywhere. The build analytics, the build cache, and publishing, it's just a couple of examples of some features which could be included in the framework. And this will really not affect any of the project structure definitions, because this is not related to project structure at all. It's only build configuration. So again, I guess this is the last slide. And I really believe we can achieve the better project structure and better build performance by replacing build configuration with project structure definitions. And I like to call this approach a meta build system, which is actually what it is. It's some abstraction layer on top of build system, in this case, Gradle, but it could be extended, I guess. And I was talking a lot about like how like this API could work and how it's designed, but it's actually a real project which implements all the APIs which I've showed to you in this talk. And this project called Former, you can go use this link you see and try it out yourself. And I truly believe you will enjoy it much more than dealing with build configurations directly. Again, thank you so much, and I'm happy to hear your questions.